Computer data storage.
Computer data storage, often called storage or memory, is a technology consisting of computer components and recording media used to retain digital data. It is a core function and fundamental component of computers. The central processing unit of a computer is what manipulates data by performing computations. In practice, almost all computers use a storage hierarchy, which puts fast but expensive and small storage options close to the CPU and slower but larger and cheaper options farther away. Often the fast, volatile technologies are referred to as memory, while slower permanent technologies are referred to as storage, but these terms can also be used interchangeably. In the von Neumann architecture, the CPU consists of two main parts, control unit and arithmetic logic unit. The former controls the flow of data between the CPU and memory. The latter performs arithmetic and logical operations on data.
Functionality.
Without a significant amount of memory, a computer would merely be able to perform fixed operations and immediately output the result. It would have to be reconfigured to change its behavior. This is acceptable for devices such as desk calculators, digital signal processors, and other specialized devices. Von Neumann machines differ in having a memory in which they store their operating instructions and data. Such computers are more versatile in that they do not need to have their hardware reconfigured for each new program, but can simply be reprogrammed with new in-memory instructions. They also tend to be simpler to design, in that a relatively simple processor may keep state between successive computations to build up complex procedural results. Most modern computers are von Neumann machines.
Data organization and representation.
A modern digital computer represents data using the binary numeral system. Text, numbers, pictures, audio, and nearly any other form of information can be converted into a string of bits, or binary digits, each of which has a value of 1 or 0. The most common unit of storage is the byte, equal to 8 bits. A piece of information can be handled by any computer or device whose storage space is large enough to accommodate the binary representation of the piece of information, or simply data. For example, the complete works of Shakespeare, about 1250 pages in print, can be stored in about 5 megabytes, 40 million bits, with 1 byte per character. Data is encoded by assigning a bit pattern to each character, digit, or multimedia object. Many standards exist for encoding, for example, character encodings like ASCII, image encodings like JPEG, video encodings like MPEG-4. By adding bits to each encoded unit, the redundancy allows the computer both to detect errors in coded data and to correct them based on mathematical algorithms. Errors occur regularly in low probabilities due to random bit value flipping, or physical bit fatigue, loss of the physical bit in storage, its ability to maintain distinguishable value, 0 or 1, or due to errors in inter- or intra-computer communication. A random bit flip, for example, due to random radiation, is typically corrected upon detection. A bit, or a group of malfunctioning physical bits, not always the specific defective bit, is known. Group definition depends on specific storage device, is typically automatically fenced out, taken out of use by the device, and replaced with another functioning equivalent group in the device, where the corrected bit values are restored, if possible. The cyclic redundancy check, CRC, method is typically used in storage for error detection and correction. Data compression methods allow in many cases to represent a string of bits by a shorter bit string, compress and reconstruct the original string, decompress when needed. This utilizes substantially less storage, tens of percents, for many types of data at the cost of more computation, compress and decompress when needed. Analysis of trade-off between storage cost saving and costs of related computations and possible delays in data availability is done before deciding whether to keep certain data in a database compressed or not. For security reasons, certain types of data, for example, credit card information, may be kept encrypted in storage to prevent the possibility of unauthorized information reconstruction from chunks of storage snapshots.
Hierarchy of storage.
Generally, the lower a storage is in the hierarchy, the lesser its bandwidth and the greater its access latency is from the CPU. This traditional division of storage to primary, secondary, tertiary and offline storage is also guided by cost per bit. In contemporary usage, memory is usually semiconductor storage read-write random access memory, typically DRAM, dynamic RAM, or other forms of fast but temporary storage. Storage consists of storage devices and their media not directly accessible by the CPU, secondary or tertiary storage, typically hard disk drives, optical disk drives, and other devices slower than RAM but non-volatile, retaining contents when powered down. Historically, memory has been called core, main memory, real storage or internal memory, while storage devices have been referred to as secondary storage, external memory or auxiliary peripheral storage.
Primary storage.
Primary storage, or main memory or internal memory, often referred to simply as memory, is the only one directly accessible to the CPU. The CPU continuously reads instructions stored there and executes them as required. Any data actively operated on is also stored there in uniform manner. Historically, early computers used delay lines, Williams tubes, or rotating magnetic drums as primary storage. By 1954, those unreliable methods were mostly replaced by magnetic core memory. Core memory remained dominant until the 1970s, when advances in integrated circuit technology allowed semiconductor memory to become economically competitive. This led to modern random access memory, RAM. It is small-sized, light, but quite expensive at the same time. The particular types of RAM used for primary storage are also volatile, that is, they lose the information when not powered. As shown in the diagram, traditionally there are two more sub-layers of the primary storage, besides main large capacity RAM. Processor registers are located inside of the processor. Each register typically holds a word of data, often 32 or 64 bits. CPU instructions instruct the arithmetic and logic unit to perform various calculations or other operations on this data, or with the help of it. Registers are the fastest of all forms of computer data storage. Processor cache is an intermediate stage between ultra-fast registers and much slower main memory. It's introduced solely to increase performance of the computer. Most actively used information in the main memory is just duplicated in the cache memory, which is faster, but of much lesser capacity. On the other hand, main memory is much slower, but has a much greater storage capacity than processor registers. Multi-level hierarchical cache setup is also commonly used, primary cache being smallest, fastest and located inside of the processor. Secondary cache being somewhat larger and slower. Main memory is directly or indirectly connected to the central processing unit via a memory bus. It is actually two buses, not on the diagram, an address bus and a data bus. The CPU firstly sends a number through an address bus, a number called memory address, that indicates the desired location of data. Then it reads or writes the data itself using the data bus. Additionally, a memory management unit, MMU, is a small device between CPU and RAM recalculating the actual memory address, for example to provide an abstraction of virtual memory or other tasks. As the RAM types used for primary storage are volatile, cleared at startup, a computer containing only such storage would not have a source to read instructions from, in order to start the computer. Hence, non-volatile primary storage containing a small startup program, BIOS, is used to bootstrap the computer, that is, to read a larger program from non-volatile secondary storage to RAM and start to execute it. A non-volatile technology used for this purpose is called ROM, for read-only memory. The terminology may be somewhat confusing as most ROM types are also capable of random access. Many types of ROM are not literally read-only, as updates are possible. However, it is slow and memory must be erased in large portions before it can be rewritten. Some embedded systems run programs directly from ROM, or similar, because such programs are rarely changed. Standard computers do not store non-rudimentary programs in ROM, rather use large capacities of secondary storage, which is non-volatile as well, and not as costly. Recently, primary storage and secondary storage in some uses refer to what was historically called, respectively, secondary storage and tertiary storage.
Secondary storage.
Secondary storage, also known as external memory or auxiliary storage, differs from primary storage in that it is not directly accessible by the CPU. The computer usually uses its input-output channels to access secondary storage and transfers the desired data using intermediate area in primary storage. Secondary storage does not lose the data when the device is powered down, it is non-volatile. Per unit, it is typically also 2 orders of magnitude less expensive than primary storage. Modern computer systems typically have 2 orders of magnitude more secondary storage than primary storage, and data are kept for a longer time there. In modern computers, hard disk drives are usually used as secondary storage. The time taken to access a given byte of information stored on a hard disk is typically a few thousandths of a second, or milliseconds. By contrast, the time taken to access a given byte of information stored in random access memory is measured in billionths of a second, or nanoseconds. This illustrates the significant access time difference which distinguishes solid-state memory from rotating magnetic storage devices. Hard disks are typically about 1 million times slower than memory. Rotating optical storage devices, such as CD and DVD drives, have even longer access times. With disk drives, once the disk read-write head reaches the proper placement and the data of interest rotates under it, subsequent data on the track are very fast to access. To reduce the seek time and rotational latency, data are transferred to and from disks in large contiguous blocks. When data reside on disk, block access to high latency offers a ray of hope in designing efficient external memory algorithms. Sequential or block access on disks is orders of magnitude faster than random access, and many sophisticated paradigms have been developed to design efficient algorithms based upon sequential and block access. Another way to reduce the I/O bottleneck is to use multiple disks in parallel in order to increase the bandwidth between primary and secondary memory. Some other examples of secondary storage technologies are flash memory, for example USB flash drives or keys, floppy disks, magnetic tape, paper tape, punched cards, standalone RAM disks, and Iomega zip drives. The secondary storage is often formatted according to a file system format, which provides the abstraction necessary to organize data into files and directories, providing also additional information, called metadata, describing the owner of a certain file, the access time, the access permissions, and other information. Most computer operating systems use the concept of virtual memory, allowing utilization of more primary storage capacity than is physically available in the system. As the primary memory fills up, the system moves the least used chunks, pages, to secondary storage devices, to a swap file or page file, retrieving them later when they are needed. As more of these retrievals from slower secondary storage are necessary, the more the overall system performance is degraded.
Tertiary storage.
Tertiary storage or tertiary memory provides a third level of storage. Typically it involves a robotic mechanism which will mount, insert, and dismount removable mass storage media into a storage device according to the system's demands. This data is often copied to secondary storage before use. It is primarily used for archiving rarely accessed information since it is much slower than secondary storage, for example 5 to 60 seconds versus 1 to 10 milliseconds. This is primarily useful for extraordinarily large data stores, accessed without human operators. Typical examples include tape libraries and optical jukeboxes. When a computer needs to read information from the tertiary storage, it will first consult a catalog database to determine which tape or disk contains the information. Next, the computer will instruct a robotic arm to fetch the medium and place it in a drive. When the computer has finished reading the information, the robotic arm will return the medium to its place in the library.
Offline storage.
Offline storage is a computer data storage on a medium or a device that is not under the control of a processing unit. The medium is recorded, usually in a secondary or tertiary storage device, and then physically removed or disconnected. It must be inserted or connected by a human operator before a computer can access it again. Unlike tertiary storage, it cannot be accessed without human interaction. Offline storage is used to transfer information, since the detached medium can be easily physically transported. Additionally, in case a disaster, for example a fire, destroys the original data, a medium in a remote location will probably be unaffected, enabling disaster recovery. Offline storage increases general information security, since it is physically inaccessible from a computer, and data confidentiality or integrity cannot be affected by computer-based attack techniques. Also, if the information stored for archival purposes is rarely accessed, offline storage is less expensive than tertiary storage. In modern personal computers, most secondary and tertiary storage media are also used for offline storage. Optical disks and flash memory devices are most popular, and to much lesser extent removable hard disk drives. In enterprise uses, magnetic tape is predominant. Older examples are floppy disks, zip disks, or punched cards.
Characteristics of storage.
Storage technologies at all levels of the storage hierarchy can be differentiated by evaluating certain core characteristics as well as measuring characteristics specific to a particular implementation. These core characteristics are volatility, mutability, accessibility, and addressability. For any particular implementation of any storage technology, the characteristics worth measuring are capacity and performance.
Volatility.
An uninterruptible power supply can be used to give a computer a brief window of time to move information from primary volatile storage into non-volatile storage before the batteries are exhausted. Some systems, for example, see the EMC have integrated batteries that maintain volatile storage for several hours.
Energy use.
Storage devices that reduce fan usage, automatically shut down during inactivity, and low-power hard drives can reduce energy consumption 90%. 2.5-inch hard disk drives often consume less power than larger ones. Low-capacity solid-state drives have no moving parts and consume less power than hard disks. Also, memory may use more power than hard disks.
Fundamental storage technologies.
As of 2011, the most commonly used data storage technologies are semiconductor, magnetic, and optical, while paper still sees some limited usage. Media is a common name for what actually holds the data in the storage device. Some other fundamental storage technologies have also been used in the past or are proposed for development.
Semiconductor.
Semiconductor memory uses semiconductor-based integrated circuits to store information. A semiconductor memory chip may contain millions of tiny transistors or capacitors. Both volatile and non-volatile forms of semiconductor memory exist. In modern computers, primary storage almost exclusively consists of dynamic volatile semiconductor memory or dynamic random access memory. Since the turn of the century, a type of non-volatile semiconductor memory known as flash memory has steadily gained share as offline storage for home computers. Non-volatile semiconductor memory is also used for secondary storage in various advanced electronic devices and specialized computers. As early as 2006, notebook and desktop computer manufacturers started using flash-based solid-state drives, SSDs, as default configuration options for the secondary storage either in addition to or instead of the more traditional HDD.
Magnetic.
Magnetic storage uses different patterns of magnetization on a magnetically coated surface to store information. Magnetic storage is non-volatile. The information is accessed using one or more read-write heads which may contain one or more recording transducers. A read-write head only covers a part of the surface so that the head or medium or both must be moved relative to another in order to access data. In modern computers, magnetic storage will take these forms. Magnetic disk. Floppy disk, used for offline storage. Hard disk drive, used for secondary storage. Floppy disk, used for offline storage. Hard disk drive, used for secondary storage. Magnetic tape, used for tertiary and offline storage. In early computers, magnetic storage was also used as primary storage in a form of magnetic memory, or core memory, core rope memory, thin film memory and or twister memory. Tertiary, for example NCRCRAM, or offline storage in the form of magnetic cards. Magnetic tape was then often used for secondary storage.
Optical.
Optical storage, the typical optical disc, stores information in deformities on the surface of a circular disc and reads this information by illuminating the surface with a laser diode and observing the reflection. Optical disc storage is non-volatile. The deformities may be permanent, read-only media, formed once, write-once media, or reversible, recordable or read-write media. The following forms are currently in common use: CD, CD-ROM, DVD, BD-ROM, read-only storage, used for mass distribution of digital information, music, video, computer programs. CDR, DVD-R, DVD plus R, BDR, write-once storage, used for tertiary and offline storage. CD-RW, DVD-RW, DVD plus RW, DVD-RAM, BDRE, slow write, fast read storage, used for tertiary and offline storage. Ultra-density optical or UDO is similar in capacity to BDR or BDRE and is slow write, fast read storage used for tertiary and offline storage. Magneto optical disk storage is optical disk storage where the magnetic state on a ferromagnetic surface stores information. The information is read optically and written by combining magnetic and optical methods. Magneto optical disk storage is non-volatile, sequential access, slow write, fast read storage used for tertiary and offline storage. 3D optical data storage has also been proposed.
Paper.
Paper data storage, typically in the form of paper tape or punched cards, has long been used to store information for automatic processing, particularly before general-purpose computers existed. Information was recorded by punching holes into the paper or cardboard medium and was read mechanically, or later optically, to determine whether a particular location on the medium was solid or contained a hole. A few technologies allow people to make marks on paper that are easily read by machine. These are widely used for tabulating votes and grading standardized tests. Barcodes made it possible for any object that was to be sold or transported to have some computer-readable information securely attached to it.
Uncommon. Related technologies. Redundancy.
While a group of bits malfunction may be resolved by error detection and correction mechanisms, see above, storage device malfunction requires different solutions. The following solutions are commonly used and valid for most storage devices. Device mirroring, replication. A common solution to the problem is constantly maintaining an identical copy of device content on another device, typically of the same type. The downside is that this doubles the storage, and both devices, copies, need to be updated simultaneously with some overhead and possibly some delays. The upside is possible concurrent read of the same data group by two independent processes, which increases performance. When one of the replicated devices is detected to be defective, the other copy is still operational, and is being utilized to generate a new copy on another device, usually available operational in a pool of standby devices for this purpose. Redundant array of independent disks, RAID. This method generalizes the device mirroring above by allowing one device in a group of n devices to fail and be replaced with content restored. Device mirroring is RAID with n equals 2. RAID groups of n equals 5 or n equals 6 are common. Greater than 2 saves storage, when comparing with n equals 2, at the cost of more processing during both regular operation, with often reduced performance, and effective device replacement. Device mirroring and typical RAID are designed to handle a single device failure in the RAID group of devices. However, if a second failure occurs before the RAID group is completely repaired from the first failure, then data can be lost. The probability of a single failure is typically small. Thus the probability of two failures in a same RAID group in time proximity is much smaller, approximately the probability squared, that is, multiplied by itself. If a database cannot tolerate even such smaller probability of data loss, then the RAID group itself is replicated, mirrored. In many cases such mirroring is done geographically remotely, in a different storage array, to handle also recovery from disasters. See disaster recovery above.
Network connectivity.
A secondary or tertiary storage may connect to a computer utilizing computer networks. This concept does not pertain to the primary storage, which is shared between multiple processors to a lesser degree. Direct attached storage, DAS, is a traditional mass storage that does not use any network. This is still a most popular approach. This retronym was coined recently, together with NAS and SAN. Network attached storage, NAS, is mass storage attached to a computer which another computer can access at file level over a local area network, a private wide area network, or in the case of online file storage, over the Internet. NAS is commonly associated with the NFS and CIFS SMB protocols. Storage Area Network, SAN, is a specialized network that provides other computers with storage capacity. The crucial difference between NAS and SAN is the former presents and manages file systems to client computers, whilst the latter provides access at block addressing, RAW, level, leaving it to attaching systems to manage data or file systems within the provided capacity. SAN is commonly associated with fiber channel networks.
Robotic storage.
Large quantities of individual magnetic tapes, and optical or magneto-optical disks may be stored in robotic tertiary storage devices. In tape storage field they are known as tape libraries, and in optical storage field optical jukeboxes, or optical disk libraries per analogy. Smallest forms of either technology containing just one drive device are referred to as autoloaders or autoch hangers. Robotic access storage devices may have a number of slots, each holding individual media, and usually one or more picking robots that traverse the slots and load media to built-in drives. The arrangement of the slots and picking devices affects performance. Important characteristics of such storage are possible expansion options, adding slots, modules, drives, robots. Tape libraries may have from 10 to more than 100,000 slots, and provide terabytes or petabytes of nearline information. Optical jukeboxes are somewhat smaller solutions, up to 1,000 slots. Robotic storage is used for backups, and for high-capacity archives in imaging, medical, and video industries. Hierarchical storage management is a most known archiving strategy of automatically migrating long unused files from fast hard disk storage to libraries or jukeboxes. If the files are needed, they are retrieved back to disk.